Good morning, Algebra 2 students. Today's lesson is on writing equations of lines. So we have a couple different forms. One of them is one that you're probably very familiar with in slope-intercept, which is y equals mx plus b. And in using this form, the m stands for the slope of the line, and the b stands for the y-intercept of the line, where that line crosses the y-axis at. We also have what's called the point-slope line, or form of a line, which is when you have a point and a slope. Your point is going to be plugged in with the x-coordinate right here, and the y-coordinate right here. And once again, your m is your slope. So this would be when you have a point with the coordinates x sub 1, y sub 1, and then a slope. Now we've already learned about standard form, which is ax plus by equals c. Remember, your a, b, and c have to be integers. A has got to be positive, and you cannot have anything, a greatest common factor of anything more than 1. So examples here. If I'm going to write an equation of a line that has a slope of 3 and passes through the point 0, negative 2. All right, we got to think about what you're given. Right now you're given a point and a slope. So the most logical form to use would be point-slope form, which is y minus y sub 1 equals m times x minus x sub 1. So then I would plug in my x-coordinate for x sub 1. I'm going to put my y-coordinate in for y sub 1. That's y minus a minus 2, which, as you know, becomes positive 2. And my slope is 3. So now I would distribute. I have 3x minus 0, which is nothing there. And then I could subtract 2. And now this equation is in slope-intercept form. I could ask you to change this now to standard form. And then we would subtract 3x. And then I'd make my a positive, and that would be standard form. Making it easy to graph that because your x-intercept would be 2/3 and your y-intercept would be a negative 2. All right, this example, we have a slope of negative 2. We're passing through a point negative 314. So again, we have a point and a slope. So using point slope, I'm going to have y minus the y coordinate, which is 14, equals my slope times x minus the x coordinate. Chop, chop becomes plus 3. I could then distribute. So I have negative 2x minus 6. I could then add my 2x. Oops. Let's be careful here. Again, depends on what form you like to get it into. I could add 14 right now. And we'd have y equals a negative 2x plus 8. That is slope-intercept form. If I asked you to change this to standard form, we would just need to add the 2x, and I would have it. This next example, now I'm given 2 points. Now we don't have a point-point method, but I do know how to determine slope. So I could find the slope of this line by my change in y over my change in x. I've got chop, chop. chop, chop. So I've got 15 over 5, so my slope is 3. Now I've got 2 points and a slope. Most logical way to do this is point slope. I can pick any point I want to. I'm going to use this point. So I'm going to have y minus a minus 5, chop, chop, equals 3 times x minus a minus 8, chop, chop. I could distribute. I could subtract 5. And now this is slope-intercept form. Standard form, I could just subtract the 3x and make my a positive. And now I've got the standard form of that line. This example says it passes through the point 4, 2, and then it says it's perpendicular to this line. If it's perpendicular, I know my slope is the negative reciprocal. If it's parallel, then we have the same slope. So the slope of this line is a negative 2. That tells me my slope, since I'm perpendicular, that would be a positive 1 over 2. And now I've got a point and a slope. Point slope, I'd have y minus 4, or y minus 2, equals 1/2 times x minus 4. I could distribute. If I add the 2, I now have slope-intercept form. If I wanted standard form, I'd have to bring my x over. I can't have a fraction here. I'm going to multiply this whole thing. Also making a positive, so I'm going to multiply by negative 2, which would give me x minus 2y is a negative 8. And that would be standard form of that line.